Okay, good morning everyone. Welcome to this session on lessons learned and future priorities for test centres. We're going to hear from 5 different speakers this morning, a variety of different test centres. And at the end we'll have a short 20-minute session so people can ask questions. The UK and Ireland have been leading the way in the development of wave and tidal test centres, and it's fair to say that we've got probably the best test facilities in the world that we can draw on. We have a range of different facilities of different scales, for different technical maturities, different capacities, and a variety of wave and tidal conditions. But it's a lot more than this. Each of those test centres have with them developed supply chains, port infrastructure, consenting, grid connections, and a whole host of other facilities available to technology developers. And as well as that, we've got experience, having seen wave developers and tidal developers deploy their devices in the past. They've seen what's gone well, and they've seen what's gone not so well. So there's a lot of experience that can be drawn on, and that's one of the things that we'll talk about this morning. But it is fair to say that technology developers do tend to underestimate the task of putting their wave device into the real sea conditions. And we've seen the result of that in the past, that things have never necessarily gone as well as they were predicted. So early engagement with test centres and the local supply chain and marine operators is really an essential thing in the development of any technology, and I would urge you to do so. At Wave Energy Scotland, we have 2 wave devices in our programme, AWS Energy and Motion Energy, who are both going to go to Emac over the summer, and certainly that's something that we followed, working with Rob up in Emac. So that brings me to our speakers, and our first speaker this morning is Rob Flynn from Emac. He's the Commercial Director at Emac, and he's going to talk us through lessons learned and what's coming up in the future for Emac. Okay, over to you then, Rob.
Okay, thanks a lot, Tim. Can you guys see my screen?
Yeah, that's all.
Cool. All right. Thanks for the introduction, Tim, and thanks a lot to the guys from Marine Energy Wales, Beth and Saul and Jess and Jay for the invitation to speak today, and hope the conference goes well for the rest of the week. So I'm going to talk to you a bit about lessons learned from Emac from the last 15 years of operation. First, I'm just going to introduce the facility quite briefly. So let's see if this works. Cool. So Emac, broadly speaking, we are a test facility based in the Orkney Islands with some grid-connected infrastructure. So a 7-megawatt wave site called Billy Crew, a 4-megawatt tidal energy test site at the Fall of Warness, and some scaled test sites that we use for testing technologies in non-grid-connected, kind of more benign environments. In addition, over the last few years, we've come to operate some hydrogen infrastructure off our tidal energy test site in Edy. So we also have a hydrogen electrolyzer that we operate there using power from our tidal energy sites, and a community-owned wind turbine, compressor, and then kind of a distribution system to bring the hydrogen back to Orkney mainland, where we can use it in a fuel cell there. Huge amount of lessons learned from operating this kind of infrastructure over the last 15 years, and the hydrogen and maybe more 4 or 5 year kind of periods. Won't be touching on that quite so much in the presentation, but happy to get into it in questions later. So yeah, as I mentioned, quite a lot of testing that's happened over the last while. 15 years, we've tested 32 different devices from 20 different developers in 11 different countries. So briefly, just a quick update on where we are at Emac at the moment. Over the next 6 months or so, we've quite a lot of activity on the sites. Magallanes, a Spanish floating tidal energy technology developer, coming back on site just before the summer. We have the Orbital Marine Power guys coming onto the site as well at the Fall of Warness with their 2-megawatt floating tidal technology. And as Tim mentioned, 2 developers from the Wave Energy Scotland program arriving in Q2 as well to test at our scale sites. So a huge amount of activity coming online over the next 6 months or so to keep the team busy back up in Orkney. A couple other projects then to mention as well. In the springtime, we'll also be testing at one of our scale sites, this in the top left-hand corner here, TFI's D400 mooring load reduction device. So kind of targeting the floating wind market, but interesting to see that we're using these sites for floating wind kind of technology components as well in the coming period. Some other bits that we have ongoing, we're doing some testing offsite as well with Verdant Power in New York. So this is really interesting. It'll be the first power performance assessment that's done through the IEC-RE system on their tidal energy system at Roosevelt Islands in the East River in New York. Also in the summer, we have a new flow cell battery that we'll be installing into our ED substation off the tidal sites from Invinity. So that's a 1.5 megawatt hour flow cell system. So really kind of adding to the complexity of the electricity system on ED with, you know, tidal energy, wind energy, flow cell battery, one hydrogen electrolyzer, potentially a second one later this year as well. And then lastly to mention, we're also involved in you know, taking some of the lessons that we've learned from consenting quite a few deployments in Orkney over the years, and helping the guys in an island on the other end of the UK, in the Isle of Wight, at the PTEC sites to help get that site reconsented and ready for the industry to deploy at in the coming years. Okay, so getting to the lessons learned bits, you know, anyone that's operated out in the marine environments will know how difficult it is, and this is kind of just some images that kind of highlight this case. In the bottom right hand corner, this is, you know, marine traffic from one day at our tidal test site, and trying to plan marine operations in this kind of an environment, given the really short weather windows that you have between tides to do operations is quite challenging. The top right hand corner here as well, you can see the seabed at a kind of typical channel tidal sites, and the kind of steep fall offs that you have here. It requires quite a lot of micrositing in order to plan deployments well. And the bottom left, you can see an ADCP that's been quite tangled up in some seaweed and that kind of stuff. So, you know, the point is kind of stuff breaks. It breaks for different reasons. Stuff's designed to handle extreme loads. But I think what we see in the kind of high energy environments that we operate in, it's more the repetitive variable nature of the loads that tends to break things. Similarly, stuff's often designed for an oil and gas application in mind, which can be for deeper sites, and the areas that we operate in the wave and tidal sector tend to be more kind of oxygenated, and you know, you have issues centered around cavitation and corrosion. So we've learned quite a bit around what breaks, what doesn't break, and when to expect it to, and you know, finding solutions for ways around that as well. Other challenges that you have then as well, it's just when stuff does break, is accessibility to the site. This is our wave energy test sites at Billy Crew, and you can see access to the site is quite limited over the course of the year once you're over that 2 meters of significant wave heights resource. So, you know, some stuff then that we have seen work over the last few years, and it's really kind of a key point for the sector in general, it's just around revenue support and how important that is for technology developers on site. It's important for them to help kind of get their demonstration program off the ground, but it's also really important to be able to show a pipeline for deployments after they test at test sites and at Emac and other places as well, just to be able to drive private investment into these demonstration programs, and that's been a real challenge in recent years. And we've been quite lucky that we've been able to have ROC accreditations at Emac, that people can get a premium on the electricity generated there. Another thing that we're quite keen on at Emac, and it's been a real strong lesson learned over the last few years, is just, you know, trying to work with as many different people from around the world as we possibly can. We've learned quite a bit over the last 15 years. You know, if we were to do Emac all over again, we probably wouldn't do the same thing. So it's kind of trying to make sure that we're capturing those lessons and sharing them with other test centers that they develop. And then, you know, it's a two-way street then at later points with more established test centers as well, where they're learning stuff that we can learn from them also. You know, working with people like PacWave in the US to help that site get off the ground, and the QNLM guys in China, but also closer to home with the team at Meta as well. Right, so this is my last slide. It's really just a point around how test centers are. I guess I was surprised when I started at Emac just how much time we spend stakeholder engagement and outreach. So it's really kind of being this kind of shop front for the industry and leading on engagement with a number of public officials, private sector officials, and giving kind of a hub or a focal point for people to come and see what the marine energy sector looks like when it's operating, which I think is hugely valuable. It's also quite a lot of stakeholder engagement, really important. Other stakeholders like regulatory bodies, the test centers tend to be typically the first people to have those kind of engagements. It's really important work as well. Right, so happy to take questions later, and thanks a lot.
Okay, thanks very much, Rob. That was great. Like Rob says, we'll take questions at the end. So moving on, next we have John Breslin, who is the Managing Director of Bluewise Marine. Some of you may know that in its previous name as Smart Bay. So over to you, John.
Thanks, Tim, and thanks everybody in Meta for the opportunity to present here. Sorry, I'm just trying to get my screen up. If you could let me know when you can see it.
The screen is up now, but I can't see any content. I can just see this.
Just bear with me, guys.
We've lost it now, John.
Is it coming back again?
No, you're not sharing anything at the moment. No, it's coming back now, yes.
Yeah.
There we go. That's it.
Okay, back in business. Okay, thanks all for the introduction. So our test site, Smart Bay, was established back in 2008. So again, like Rob, I just want to share some of the lessons learned and talk about some of our future priorities as well. But in terms of Bluewise Marine, we've rebranded, and the reason we've done that is to expand our services. I suppose the learnings and experiences that we've gained over the years in Smart Bay, we're now trying to, I suppose, promote them and provide those services to developers of wave, wind and tidal projects within Ireland. So we provide asset project marketing and stakeholder management services. What we mean there is everything from site identification and identifying stakeholder concerns, fisheries liaison, preparing scopes of work for geotech, geophysical surveys, that kind of thing, community engagement, then developing sort of plans for engaging the community and communicating what the project is about. So enough about us, let's back to the test site. So in Ireland, we have a suite of infrastructure. In Cork, we have the Lear National Ocean Test Facilities for the smaller scale devices. These are test tanks, a range of different test tanks and facilities there. Then Galway Bay is an intermediate scale test site. It's not grid connected, but we do have an observatory, and it's for testing a TRL 4 to 6. And then we have the Atlantic Marine Energy Test Site, which is being developed at the moment in an extremely high energy environment. So the idea is to take technologies, be they wind or tidal or floating wind, wave, floating wind or tidal, up through the TRLs. And I suppose the step from Galway Bay is more likely to be somewhere like, you know, Emac, and then on to Amets or possibly Hawaii, for example, in the case of ocean energy. Our test site is, it has 3 test berths. One of them can be used for testing floating wind devices. I mentioned we have a subsea cabled observatory. So that's for testing sensors and equipment in an underwater subsea environment. Effectively, the infrastructure provides our eyes and ears under the sea, so we can monitor the environment in near real time via the cable, and people can develop different ways of analysing, visualising data and testing sensors. Also on our data buoys as well, communication systems, lots of different applications, and that's what we've focused on. It's expanding beyond just the actual testing of the devices themselves, and we focus on subsystems and components. So I suppose one of the major lessons learned for us anyway was that when the test site was initially set up, we had a couple of devices, Ocean Energy and WaveBob, but a lot of the operational team was actually based in another location. And I think we didn't, well, with the benefit of hindsight, we didn't put enough effort into engaging with local residents. And when we went for the extension of our lease for another 35 years, we had quite a bit of pushback. And unfortunately, the pushback was from a small number of people, but we didn't have the support of the community because we weren't really there. We didn't have the presence. We've changed that now. We have a community engagement coordinator there. We're developing schools, programs, events, identifying funding opportunities for the community. You know, informing the community in terms of everything we do via social media now in these COVID times. We're coordinating educational initiatives as well. So really trying to make as many people in the community aware of what we do. There's nothing to hide, and to try and identify if there's opportunities for benefits, I suppose. Another lesson learned is, because it's not a grid connected site, and I suppose we feel that testing at this smaller scale is invaluable because it's a lot cheaper before you go to full scale. But a lot of developers like to skip that, and I'm not saying all, but some have skipped that step. So we looked at trying to diversify and focused very much on everything from connectors, coatings, materials, different subsystems, communication systems, different types of sensors for measuring wave heights. We've undertaken almost 70 projects now on the test site since we established it, and I suppose that has really extended our reach into working with academia and developers of different types of technologies in different sectors. And I suppose from a test site perspective, that's important. That diversification is important. Use your infrastructure, maximize the return on the investment, because that's also a way of leveraging funds from Europe as well. So another lesson learned is, it's been mentioned by Tim and Rob, this is it's a fundamentally a dangerous environment. It's a challenging environment. It's corrosive. People can get hurt. So accreditation, I suppose I come from a shipping background originally, and so when we started operating the test site back in 2012, we went towards ISO accreditation, and that makes you, I suppose, think before you do. We've got accreditation under the environmental standards, quality standard, and health and safety standard. So preserving life, human life, people who work on the test site, is absolutely paramount, as is preserving the environment and the plants and animals that live there. And again, you can only do that through kind of systems and procedures. Also, the last thing anybody wants is a device breaking its moorings or sinking, becoming a wreck, becoming a pollution hazard. So we developed guidelines to assist developers through third-party verification. We insist on third-party verification as well. So we're looking at the materials that have been used, the design characteristics, the planned operational procedures, and independently vetting them before a device goes onto the test site. We've developed systems of operations, maintenance, procedures, safe systems of work. Again, anything being done in the sea needs lots of thought, lots of planning. We have our ongoing environmental monitoring via the observatory and the data buoys, which is useful for the requirements of the lease. Supply chain engagement is key, and vetting the supply chain is key as well. So we evaluate, we make sure the right insurances are in place, and then customer feedback for continuous improvement has been very important. Again, and Rob has touched on this, working together, the test sites have come together, led really by Emac from our experience back in 2016 with the 4C project. An excellent project that brought Emac, SEMREV, DMEC and SmartBay together. We were able to, I suppose, work better as a group, leverage funds not only for our own time, but also for developers to come and test their devices in the infrastructure. So it provided better access to finance. We had more impact by jointly working together. It allowed us to coordinate our activities and, I suppose, develop relationships which moved on to different collaborations through various workshops. So the future priority, the big one for Ireland, is the construction of the Atlantic Marine Energy Test Site. Test Site A is the one that will be developed. That's in 100 meters of water depth. When this is built, this will be the test site that is located in the most energetic environment in the world from a wind and wave perspective. If a device can survive in Amherst, it's going to really be able to survive anywhere. You can see the significant wave height characteristics there. I mean, Hmax, we've got significant wave height recorded at 16 meters. Hmax goes off the scale beyond 25, 26 meters for the wave riders. So we reckon probably that the real Hmax is somewhere around the 30 meters. So an extremely challenging environment. Access will be a huge issue. I mean, we can look here in terms of 2 meter significant wave height. So even, I suppose, the solutions that will have to be developed to get people or to inspect these devices will have to be novel. So in terms of future priorities, we will continue to promote the SmartBay Marine and Renewable Energy Test Site. The Atlantic Marine Energy Test Site, we're starting at an early stage in that. We've got to identify the supply chain, as I said, develop the test site access procedures, the health and safety, environment and quality management plans. We're going to develop a pipeline of users for the facility. The infrastructure has to be procured. and of course the cable has to be installed and commissioned. So a huge body of work to be done there, but I think a huge opportunity for collaboration with our colleagues, our partners in Meta and other test sites as well, because again, it's all about, I suppose, not trying to reinvent the wheel, learning where things haven't worked well, and getting advice, and this was collaborating. So continued engagement within test sites is key, and collaboration is key. And I suppose just to finish on, community engagement for us is one of the biggest learnings. We probably got the biggest scars from that. So look, thanks for listening. Looking forward to the questions at the end of the session.
It was a very comprehensive run through of your facilities. Next, we're going to move to George Crossley, who's the site manager at FabTest. FabTest, for those who don't know, is the Falmouth Bay test site. So over to you, George.
Hi, everyone. I hope you can hear me.
Yeah, we can hear you.
Great. Thanks to so many of you for coming. Listen to talks. Let's see if I get these slides up. There we go.
Yeah, that's up now.
Okay, great. Hi, everyone. I'm George. I manage the FabTest facility, the Falmouth Bay test site in Falmouth Bay in the south of England. I manage the site, and I also work on a Marine Eye project, which is an ERDF-funded research project around marine technology. So the site, as many of you will know, is in the south of Cornwall, in Falmouth Bay. I think it's important to sort of consider how all of these sites are slightly different. We all have our own attributes, and I think the sort of top differences between FabTest and maybe the other sites is that we are sheltered from the west and southwest, so we avoid a lot of the most extreme Atlantic weather. We still get significant weather from the south and from the east, but due to this sheltered aspect, we have very high accessibility to the site, whilst also on occasion experiencing some big waves as well, and all within easy reach of Falmouth, which has a fairly comprehensive set of facilities, a lot of different contractors with different expertise. The site's pre-consented, so very easy to access. Hopefully, from the time of application, we would get a developer onto site within 8 weeks. And there's no grid connection, unlike a lot of the other sites. We have a range of depths from about 20 to 50 meters, and then in the harbour, a huge range of different expertise, wharf space contractors, the university, and we work very strongly in collaboration with Falmouth Harbour Commissioners who bring a huge amount of knowledge and experience to that. So we've been monitoring, collecting data on the site and around Cornwall for a long time now. For about 10 years, we have continuous wave buoy data for the site, and also we have modelling capability from the university and plenty of other instrument deployments to draw data from. So that's always very important to developers as they come towards using the site, and to have that knowledge of what's actually going on at the site at the time. So sort of quickly getting to the lessons we've learnt. I've been in post 3 years or so, and I've certainly learnt a lot. And I think all my predecessors as well would say that they've learnt a lot from testing offshore and helping developers to test offshore. I've got a lot of experience now in deploying marine instrumentation. Instrumentation does fail. Occasionally in bad weather you'll lose instrumentation. Sometimes you'll find it again. and we've learned a huge amount over the last 10 years about what works and what doesn't, and the robustness that's required in such an environment. So would be really happy to talk more to anyone who's interested in learning more about what works in these certain situations. In terms of wave energy, I think some important lessons have already been highlighted by the other site managers. I think one that I would focus on that might seem obvious to a lot of us who have some experience, but there are occasionally a developer will come to you who doesn't necessarily understand the cost associated with the vessel operations, and in particular the vessel operations. Obviously the whole project is likely to be expensive, but I think I always try and make developers understand what that cost is, and I think that's really important to be clear on that before starting. And then the other lesson that I'd also like to just highlight now is that in my opinion, reliability is more important than efficiency. Something that breaks will be very inefficient, and so having that absolute robustness that you are 100% sure that it's going to be reliable in what is quite an extreme marine environment, even in such a sheltered location as Falmouth Bay, is absolutely critical. So I'm going to stop there to take questions later on, and if you want to email me as well with any questions that you don't have time to raise in the panel, then that would be really great. So thanks a lot everyone for listening.
Okay, thanks very much, George. That's great. We will take questions at the end, as I said. Now let's move on to Sue Barr, Director at Cambrian Offshore. Not entirely sure what Sue's going to talk about this morning.
Thanks, Tim.
So over to you, Sue, and let's see if we can get your slides to work now.
Fingers crossed.
That's it.
Perfect. Well, good morning, everybody, and thanks for the opportunity to come and talk to you. And thanks to my previous speakers who have really highlighted the importance of having equipment in the water and the learning that can be derived from that. Tim raised a question on what will I speak about. That's probably because I wear multiple hats, but what I wanted to really showcase this morning is an opportunity in Wales for a project that was previously a tidal test, well, a tidal deployment that we're looking to develop into a tidal test site for Wales. This project is Ramsey Sound. It is funded by the Interreg Channel Manche programme and Tiger. For those of you that aren't aware, Tiger is the Tidal Stream Industry Energizer project. It is 19 project partners across France and the UK, focusing on deployment of tidal technology. This project is managed by the Offshore Renewable Energy Catapults. Some of you are in the audience at the moment, and it's really an opportunity to get tidal stream technology in the water and share the learning from that. So where is the site? So this is Ramsey Sound. We're at the Marine Energy Wales conference. So I wanted to talk about this as an opportunity for Wales for scaled deployment of tidal stream technology in a site that is located in the west of Wales, just at the back of St David's, between a channel that's Ramsey Island there in the distance that you can see above the old lifeboat station, and this is St Justinian's. Behind St David's, the smallest city in the UK, but some excellent tidal resource there in that channel. So we've got Ramsey Island. We've got a very strong tidal stream site that was identified by a company called TEL many years ago, back in 2010, 2011, when they looked to deploy their Delta Stream device, which you'll see at the bottom of the page there, So a triangular base foundation with horizontal axis turbines on it. They did deploy that turbine. They deployed it in late 2015 with a single 400 kilowatt nacelle on that device in a showcase project for Wales, really, an at-scale deployment of tidal technology. Unfortunately, that project was shelved in early 2016, and the site has lay fallow for that period. We identified an opportunity to really regenerate that site back in 2018, 2019. And the reason we felt that was important is for many of the reasons that my previous colleagues and speakers have raised, is around the need to demonstrate, the need to learn, the need to gather data, and the need to work with stakeholders to really improve the perception of tidal stream technology. The site is fully consented, the infrastructure is in place. So there's a cable that runs down the slipway on the right-hand side of that lifeboat station there and out into the centre of Ramsey Sound. You can see the red star where the deployment location is. And Delta Stream, the technology that TEL developed, is actually deployed on the seabed there. So this project is to look at how we utilise that infrastructure to the best of its ability. It's a strong site, it's got some good flows, they're very interesting, and we know that there's a lot of academic research into what those flows look like. And it's a 400 kilowatt ROC accredited site. So we heard from Emac about the importance of revenue and the ability. So a real opportunity for Wales to look at how we develop a site. So what are we hoping to do and who are we? So Cambrian Offshore was incorporated in early 2019 to really look at the opportunity to disseminate the data that was derived or could be derived from that initial deployment of Delta Stream, but also build on the infrastructure, build on the opportunity. And we've seen the challenges in terms of getting sites consented, in terms of finding funding to build infrastructure. Well, this site already has that in place. So here we have the onshore substation and the offices, which are enabled to sort of connect and look at that turbine in a live environment. There's also data collected from the operational period of Delta Stream, which we feel is really important. So we are starting out on the journey of trying to develop this site, utilise infrastructure and build capability in Wales for marine energy. We've got a good team and we want to secure that knowledge and capacity at the site to make sure that we can feed into the requirement for Wales to increase understanding of what it is to deploy technology at scale. And we've seen that locationally around the UK, we have a number of sites in Ireland. Really, really important to get equipment in the water. Having been in the sector for a very long time, when we first saw the likes of Force and Emac start to build projects and start to get equipment in the water, that's when we start to see good data, we start to see good stakeholder engagement, and we start to see changes in policies. And I know there's some questions about barriers to deployment. Really getting knowledge and capacity and collaboration is very, very important. So what are we intending to do? You'll see here the Delta Stream device, the Welsh Daffodil, really a successful project deployed in Ramsey Sound with an operational period behind it. We don't want to lose that. We need to be able to use the information from that operational period to really forensically analyze this deployment. It's one of the first sites in the world to be regenerated. We've had some decommissioning experience, but what happens when you bring this equipment out? What is the status of that steel? What level of corrosion are we seeing? What happened to the hydraulics? What level of biofouling can we see on this machine? What is reusable? What is not reusable? All really, really really valuable data. And we've really at this stage started to collate and analyze the data. And we know we've got some interesting conclusions that we'll be able to rise from that, but there's still a lot of data to be mining. So the first stage is to recover that turbine, and we'll do that as part of the Tiger project. The second stage is to look at redeployment of an operational turbine. So we have a requirement under the Tiger program to get an operational turbine back in the water. And this site is one of the first in the Tiger project that will be able to do that. We have consent, we have grid connection, and we have the ability to move forward and do that. What we do with this turbine will be dependent on a number of contingencies and factors, but we're hopeful that we can do something that is useful not only for the site, but also for the sector at a much larger base. So really recover, refurbish and redeploy and redevelop the site to ensure that that infrastructure and the committed spend that we've seen to this project is not lost. Testing in all areas. So I think we've heard again from other speakers, it's been very useful because clearly this site is just starting out on its journey. But the importance of empirical data, the importance of that qualitative and quantitative data from sites to give an underpinning reality to the delivery of tidal stream technology, but also wave and floating wind technology, critically important. And developing these sites helps equipment get in the water at the lowest cost and lowest risk. And we've heard about the importance of standardization, of safety, and of sharing and collaboration of knowledge. So we want to use that post-deployment information and really continue to collect data on this site. What has happened to that turbine while it has been sat on the seabed? What load cycles has it undertaken? What can we help and what can we disseminate that will help support future developments? The importance of this for Wales, I want to reiterate, where we have seen advantages and progress made in marine energy is where there are live sites. The European Marine Energy Centre, as an ex-Open Hydro employee, we were the first deployment in that site, the first technology to go in the water there. Critically important, an absolute foundation of developing technology is the ability to get in the water quickly, to have infrastructure prepared for you, consents prepared for you. So these test sites are critically important, but we must make that time in the water count. And the uniqueness of this project and this site is that we hope to be open. We hope to be able to disseminate that data through the Tiger project on a whole range of engineering, environmental impact and operational capacity. So really being able to share that information within Wales, bring the policy position forward. And I think this site sits very, very well with the network that we're looking at in terms of Pembroke Dock Marine, the Marine Energy Test Areas Meta, and we're about to hear from Saul on that. But certainly having an at-scale test site alongside the development sites we're seeing in Wales, really, really important. So that's the project. We're hopeful that we'll be able to start moving forward in this first quarter. I think COVID has been very challenging, and I'm sure it has been for other test sites in terms of operations. These are challenging environments. So I would encourage the idea of collaboration. If there's any questions I can help with on the site and how we're progressing, we will have a website soon. And we're hoping that from this site, we can get some really good open source data and dissemination both through the Tiger project and through the next deployment of an operational tidal turbine in Wales. So thank you very much.
Okay, thanks very much, Sue. That's great. We're just about to move to our final presenter. But before we do that, can I just say, if you have any questions for any of the presenters today, if you just want to put them in the chat, and I'll read them out as we move into the question and answer session after this one. Okay, so the final presenter is Saul Young from META, which is the Marine Energy Test Area in Pembroke. Over to you, Saul.
Thanks, Tim. I'll share my screen. So can you see that all right?
Thumbs up, yeah, great.
Excellent. Okay, so thanks for this opportunity and thanks to all the other presenters. It's really interesting to hear lessons learned from the more experienced test centers, which we'll try and incorporate into our own work. Okay, so I'm going to rattle through what META has to offer along with some of our lessons learned and future priorities. We provide pre-consented marine energy test areas to remove the time, cost and risk for developers associated with consenting. All of our sites are fully consented for various testing scenarios, including options for marine energy component and sub-assembly testing and scale and full-scale device testing. The META sites are located in and around the Milford Haven waterway. The location was chosen for the variety in site conditions and to take advantage of existing port infrastructure associated with Pembroke Port, as you can see pictured, and existing supply chain and contractors based in the area. So META is a Pembrokeshire Coastal Forum project led by Marine Energy Wales, and aim to support growth in the sector, and we work closely with Port of Milford Haven, Marine Energy Engineering Centre of Excellence, our academic partners, and the Test Centre network. So we have 8 fully consented sites, which are split into 2 phases. Meta Phase 1 sites are sheltered, easily accessible quayside sites, all associated with Pembroke Port. The sites are ideal for sub-assembly or component testing or dip testing devices. And across the 5 Phase 1 sites, we have multiple depth, mooring, deployment and recovery options. Phase 2 sites are our moderate high energy sites for operational testing of scale and full scale devices. The sites are Warrior Way Tidal Test Site, Dale Roads Wave Test Site, and East Pickard Bay Wave and Floating Wind Test Site. And with all our sites, these are fully consented, provided the project fits within our broad project design envelope. So despite the challenges of 2020, we've had some notable successes. Firstly, the Pembroke Dock Marine project was given the green light. Meta projects on this project with the Port of Milford Haven, Wave Hub, and the Marine Energy Engineering Centre of Excellence, led by the Catapult. And the programme will deliver facilities and services and spaces needed to establish a world-class centre for marine engineering. So a really high-value project, which we're delighted to be involved in, and massively exciting news for us and the sector in Wales. Secondly, a key achievement was teaming up with Emac to develop an operational management system for Meta. So drawing on their expertise and experience to kind of develop best practice procedures that will govern the day-to-day management of our sites. So that was a great success. And finally, you may have seen in the news recently or this week that we have gained our marine license for Meta Phase 2. So this is a huge milestone for us, the result of 3 years of hard work, and puts us well on the way for our sites to be fully consented and operational. Okay, so in terms of lessons learned, as a newly operational test centre, we don't have much to report in terms of operational lessons learned as yet. We aim to start deploying devices this year, so hopefully by next year we'll have more to say on this. And in the meantime, it's been really helpful to hear from the other test centres about their experience that they've gained over the years, and we'll be looking to incorporate those lessons learned into our operations. And so we have a few lessons on consenting, the process that we've recently gone through. So firstly, as a test centre, we wanted to facilitate testing of a wide variety of novel marine technology, so consenting broad project envelopes for a variety of sites with different resources that cater for different technologies at different scales was really important. So we balanced that need for flexibility with consenting and EIA requirements. Secondly, our stakeholder engagement was a key success, fostered support and reduced potential delays in the process. So key to that was really engaging early, agreeing points of contact for efficient communication, establishing a strategy everyone was on board with, and making sure that all of that was well documented, so could be easily referred to. And finally, key for us was contracting external expertise. So RPS consultants have been integral to ensuring our design envelope is flexible while taking due consideration for potential environmental and consenting risks. Okay, some future priorities to finish. So our mission at Meta, as I mentioned, is to reduce the time, cost and risks faced by marine energy developers in order to accelerate growth in the sector. So to achieve this, our priorities are to facilitate developer access to consented testing areas. So as we've heard from the other panelists, getting kit in the water and real sea testing, validation and demonstration is key to technology development. So by offering pre-consented test sites, we aim to help developers get their devices in the water quickly with reduced time and cost. Our second priority is to support growth in the marine energy sector in Wales. So for us, we hope that by using Meta for sea-based trials, developers can test their technology while also getting established on the ground in Wales. And then within the Welsh context, Meta is effectively a stepping stone facility from tank testing offered at Swansea University to grid-connected sites at Ramsey Sound, and in the future, the Welsh demonstration zones at Morlais and the Pembrokeshire demonstration zone. And also, as Sue mentioned, test centres are key to building capacity and stimulating growth in the sector. So for Emac is a prime example of this, with its sites and activity stimulating supply chain growth and infrastructure developments locally. Our third priority is to add value to the test centre network. So as we've heard, all test centres offer something slightly different in terms of scale and location, and together form a robust network and the key to stimulating marine energy activity in these key areas. And we think Meta complements the existing network nicely. To collaborate, a key priority of ours, we already collaborate with a lot of valuable partners who I briefly touched on, and we aim to build on these and bring in skills and expertise where needed and add value to projects. And finally, we want to ensure we operate with the highest standards of health and safety at our sites and ensure we safeguard the environment. So we believe this, alongside the successful completion of projects, is key to building confidence, and we intend to do this through safe systems of work and third-party verification of certain tests going in the water, and through health and safety and environmental management plans, which John talked about a little bit, so I won't go into this in detail. And in the near term, the aim for 2021 is to deploy and test the first devices at Meta. Okay, so I'll leave it there. Thank you for your time, and look forward to the questions and discussion.
Okay, thanks very much, Saul, and thanks to all the panelists. I think that you've given us a pretty comprehensive view of all the test facilities that are available to potential developers. So thank you very much. Let's move on to a few questions then. Again, if anyone has any questions, just stick them in the chat and then I can ask the panelists. To start with, I've got a question from Tom Adcock, and this is for you, Rob, about the rate at which development at Emac and the number of installed devices has progressed over the years since Emac was conceived, and what have been the main sort of successes in achieving that progress, or indeed the barriers that have slowed it down.
Yeah.
I seem to remember you used to have a really good slide at Emac that showed each year and the progression and the number of devices, and it was almost an exponential curve at one stage, wasn't it?
Yeah, that's right. So I guess it ramps up to about 2014 or so with a lot of activity on the tidal side, and then a bit of a more barren period, and then kind of ramping up again in more recent years. I think a lot of activity, if I think about that kind of trend, that Emac was originally driven by, well, firstly, large OEMs coming into the sector on the tidal side, but also underpinned by a very strong revenue support system. People were able to get 3 or 5 renewable obligation certificates for generating electricity at Emac, and that was important, but it was also important that they could show a pipeline, as I said in my presentation, to market afterwards. So I think that was really a main driver. There was a few high-profile failures then as well on the wave energy side, which I suppose hampered progress a little bit in that sector, and confidence took a bit of a hit. I think in recent years we've seen confidence return to the wave energy sector, in no small part due to the really good work actually at Wave Energy Scotland. And I think really, yeah, confidence is such a massive underpinning of that kind of story around how you can leverage private finance into technology development programs. That's really quite important, I think, to the state of the sector in general.
Okay, thanks, Rob. That's great. I think you're right. Confidence is very important, and certainly the confidence that was injected into the sector in the early days with the direct revenue support packages that we saw was very important. And I think if we're on that subject, it's probably worth bringing Sue in to see if you have you got any view or comments on perhaps the state of market support and what might happen there to help us increase the sort of interest in marine energy, both wave and tidal, within the future?
Yeah, so very, very briefly, and I'll try and keep it on a test centre perspective. If we look at where revenue mechanisms have been successful, if we take Canada, for example, so they brought in a feed-in tariff, which is encouraging developers to go and use the Bay of Fundy in terms of testing and also access to revenue. Emac had access to rock accreditation, as has the Ramsey Sound site. And really, we need to have technology in the water to build the exposure or the understanding at a policy level of what this technology is. We lost access to contracts for difference a couple of years ago, and the sector has been working very hard to demonstrate its levelized cost of energy reduction and trajectory, its ability to supply, and I know there's a few questions on supply chain that we'll come on to, Tim, but how are we going to build this sector and build an industry here in the UK? And Rob has alluded to it, I think we've all alluded to it, without a route to market, without line of sight and confidence from the UK government that this sector is worth supporting through a revenue mechanism, it's very challenging. So we've been working very closely with the UK government as a sector through the Marine Energy Council, RUK, Marine Energy Wales and Scottish Renewables to ensure that there's access to a route to market. And that should be a complete pathway through from early stage R&D, which requires that capital grant investment into companies to bring forward technology through the early TRL levels, into that area where you are pre-commercial but demonstrating, and you might want to put a number of devices in the water. And for that, we're looking at an innovation power purchase agreement and through to commerciality. And what we've asked the UK government for at the moment is access for 100 megawatts within the next administrative round of AR4. All of that, and we feel that's quite positive. We feel that there's an opportunity there that we might see a change in the CFD that is positive for marine energy, but that's only driven by underpinning data, both qualitative and quantitative data, empirical data that comes out of testing this technology. And if we don't have technology in the water, we can't ask or prove that we're worth supporting. So really, really important that we have these test centres to be able to underpin the policy asks.
Okay, great. Thanks, Sue. Moving on to a question on supply chain. Graham Morley has asked, where in your business to date have you seen the largest positive effect on the supply chains? And what are the lessons learned in developing these supply chains? John, can I go to you first with that one?
I suppose in terms of our test site, where we see a ramp up of opportunities for the supply chain is when we have devices in the water. So when we've had, more recently sea power in the water, then we have a requirement for local crane operators, divers, vessel suppliers, again, ocean energy before it, and Waveball before that. There's ongoing supply chain needs. Unfortunately, I suppose one of the challenges we have is we're on the West Coast, and getting access to the vessel that you want when you want, because we don't have enough work to guarantee a vessel owner that it's worth keeping their vessel in the area. So that's always a challenge for us. I think it'll be a challenge with AMETS as well. However, there is a bigger port up there with more, with larger vessels available. Something we're doing on, I suppose, we're recognizing there'll be a big development in fixed wind in Ireland, and we've developed the Marine Ireland Industry Network. So that's a network of supply chain companies that we're trying to upskill. And some of those companies will, I suppose, cut their teeth on the test site, and they will be bidding in for work. But we're kind of encouraging some of our Irish companies to go and bid for work in the UK to get that experience when they come back to Ireland. We start developing, fixed wind will come first in Ireland in terms of commercial development, then floating wind, and then it'll be followed by wave. So I think the clustering network approach is really, really useful. And then I suppose you need to have big projects to attract in the supply chain.
Thanks, John. Can I come to George on that one?
Yeah, sure.
On your views on the supply chain impact?
Yeah, in terms of local supply chain, I mean, the Marine Power Systems project at FabTest a year or two ago, had fantastic benefit to the Falmouth maritime industry. There's 3 or 4 companies there who've really benefited from that fairly long-term deployment of a device, and who've taken income from that. And maybe at the start they were sort of fitting the wave energy stuff in around the other jobs that they had in Cornwall, to make that kind of that cost sort of reasonable for the developers. But towards the middle of the project, they would be fully focused on that wave energy device, and that's brought them income, but brought them confidence. And then having another developer, Amog, follow that directly, gave those several businesses that confidence that, oh, okay, there might be a bit of industry here that we can focus on. And then with the help of some European development fund, towards some of those companies aiming at marine renewables, they're then able to develop some of the specific technology that they might need to help the industry. And that's been really, really beneficial for the region, I think. And now we look towards more floating wind, but we hope that the wave energy stuff will keep coming in, and that supply chain is really, it's been able to build around what we've been doing, which is really good. And in terms of the lesson learned from that, I'd say that maybe we could have made more of it at the time, and maybe publicizing the beneficial effect to the region that the marine renewables has is, I think, something that maybe we've not done so well, so making a big thing of that would help bring in further investment. That's my take.
Okay, thanks, George. Can I come to you, Saul, and then I'll just give you a chance, Rob, at the end to finish off.
Yeah, thanks, Tim. In terms of supply chain, part of the reason Meta is located where it is and we consented those sites was because there's existing supply chain and infrastructure and facilities associated with Pembroke Dock, and the Pembroke Dock Marine project is going to accelerate and bring a lot of growth there further. So that's something we hope to provide a demand for and stimulate that activity and capacity there. So I can't say anything in terms of our experience or lessons learned, but that's something we hope to achieve through kind of operations at our test site.
Okay, so Rob, do you want to come in?
Yeah, thanks, Tim. And hi, Graham. Hope you're well. Yeah, I mean, the supply chain story is such a huge part of the Emac story, and really thinking about in particular the marine operators that operate up there, and the knowledge and expertise that have been developed through those operators really puts them in a world-leading position in terms of being able to deliver marine energy deployments at sea, and that's just such a huge part, I think, of. I think they've been able to do that because there's been quite a volume of activity at Emac as well. As I said in the presentation, it's about 32 deployments. We'll have about 6 things going in the sea of various types over the next 6 months. So there's a lot of work to be done there. So they've had that opportunity to build up that kind of expertise and knowledge base. But yeah, I guess that probably won't surprise people, but the marine ops side of the supply chain is very, very strong in Orkney.
Thanks, Rob. Sue, do you want to come in?
Just to reiterate the point, I think supply chain absolutely incredible, and I'm seeing some comments about what do we need first, but actually the building of the supply chain will be in multiple fronts. So development of test centres can stimulate that. We can see synergies across the different sectors in terms of the O&M. We know that building that experience, and I think Emac is a great example, having that numerical, almost a kind of measuring of what are the supply chain impacts, the GVA, the socioeconomics, really important. But we're certainly seeing that our ability to underpin the sector is really important, and it will be on a range of different areas, both tidal, stream, floating wind, wave, and offshore technologies. So we know that we can simulate the supply chain, and that will have the added value of sort of multiplications of efforts. So it's something that certainly that policy is requiring us to do. If we want a route to market, we have to prove we're going to really stimulate supply chain.
Yeah, absolutely. Thanks, Sue. Okay, we've got a question on consenting now. Kath Wallard has asked, do we feel that it's more important about people being involved, good working relationships, cooperative and collaborative approach that is important, or is it things like consenting legislation, guidance that are more important for facilitating consent? I think, John, you talked about this in your presentation about consenting and about the local approach. Do you want to respond on that one first?
I suppose it's a huge challenge because the legislation has gotten so complex, and so on one level there's having support with your local community for the particular project. But I've seen the documentation that was used for the first 10-year lease, and it's yay high, it's maybe 3 inches. And then for the second lease application, it's 2 feet. So it's a massive drain and a massive, I suppose, challenge for government departments who have to wade through all of the legislation and get everything right. And I suppose that's the challenge we've had. Okay, there's bringing the public along, which is key, but then there's the ability of the system to understand the legislation and to take all of the court precedents into account. And that's where we fell foul when we had an appeal to the award of the lease on our test site, that some of the recent precedent wasn't taken into account. And that's really tricky. So from a developer perspective or a test site operator perspective, you're ticking the boxes, you're doing everything right, you're doing the impact assessment, but when it goes to the system then to process it, that's a big problem. And in Ireland, we have, individuals who like to challenge the system. So I think the complexity for me is one of the key things that we're really worried about when we look at the development of fixed offshore wind in Ireland. And maybe because we're behind the UK in that regard, that you've been doing it a bit more, but appeals, judicial reviews are commonplace throughout Europe. It's just a complex environment. I suppose that's my biggest fear in terms of new developments and projects, actually the system's ability to get it right, because it's not easy.
No, absolutely. Thanks, John. Rob, do you want to come in on consenting? I mean, your consents have been in place for some time, but I think you have done some more recent work, haven't you, on consenting?
Yeah, I mean, with regards to the question, it's really everything John said and everything in there. It's hard to prioritize any of these areas. They all need to be taken into account and taken quite seriously. I guess the one thing I would say about the process we've gone through at Emac has been a very collaborative one with Marine Scotland, and I think that's really been quite helpful for getting the process as streamlined as we possibly can. And I think that's a relationship that we quite prize and seek to foster and try and be as, I suppose, positive and collaborative in our engagement as possible. But yeah, that's about all I have to say, really.
Thanks, Rob. Sue, do you want to come in? And then I'll come to you, Saul.
Just very briefly, as an ex-regulator, which I don't know whether that's a good thing to say in this forum or not, but I do believe that we need to change the view of and really work with regulators to help them in their administration of the legislation. So we licensed MCT's device in Strangford Lough and SAC. We've allowed projects to go ahead in British Columbia with very little monitoring. We've got a really great suite of data now that, and I think what John is alluding to is the transferability, those precedents. where have we learned before, and what can we apply to the receiving environment that we're looking at? And I think we need to work collaboratively to get to that common position. But I reiterate the point: without kit in the water, a lot of the key consenting issues that we stand to be challenged on, we can't substantiate. We won't be able to really look at the impact assessment and reach a level of understanding. So I do think you need equipment in the water first, both for revenue and for the ability to underpin, because we need to bring people with us. And I think we often forget as a sector that a lot of regulators deal with a huge range of offshore issues, whether it's coastal protection, dredging. We need to have the data, the empirical evidence, to be able to prove or disprove and help with the administration of legislation, and that is both people and knowledge capacity.
Okay, thanks, Sue. Let's come to you, Saul, your views on the consenting issue.
Yeah, thanks, Tim. Just to draw out, as Sue has mentioned, in terms of evidence and collaboration with regulators. So you may have heard yesterday in the planning and policy session about CSAG and the CGIP project. So that's the Consenting Strategic Advisory Group. So that brings together industry, regulators, environmental NGOs, and stakeholders in the industry. So, and kind of looks for a collaborative, solutions-based approach to those consenting issues that are industry-wide. And CGIP is out of that as well, which is a evidence-based or a group looking to build that evidence base. So the information that Sue's talking about in terms of finding out what monitoring questions we need to answer, and then making sure that evidence is collected and accessible, and then informs consents. So that's a key part of that process, and highlights the collaboration point there as well. And yeah, just in terms of Meta itself, I think one of our key successes was our local engagement. We've got folks on the ground here, and that's fostered a lot of support for the project, I think. We've got ongoing channels of communication with all our stakeholders. But yeah, that's for me. Thanks, Tim.
Okay, thanks to Saul and George.
So at FabTest we've been seriously looking at floating wind consenting, and the two major things that we're up against are visual impact and bird impact. And I think it's important, certainly important, to engage stakeholders early in AONB and the RSPB at an early stage on both these issues. And it's good to feel that it's not a battle. We're it's hard sometimes for us as renewable energy people to not to think that renewable energy is the only thing, and we have to consider that we're also at a point of great extinction, and so biodiversity is of huge importance as well. And for a lot of the places that the test sites are, tourism is also a major thing, and so it's not a fight. It's trying to find a mutually beneficial solution for everyone. And Natural England have been absolutely fantastic so far. I was pleasantly surprised, to be honest. Really good communication, and are really keen to find the optimum solution for everyone. But I would say that I find working with the Marine Management Organisation much more difficult, much more inaccessible. It sounds like this is quite different from working with Marine Scotland. It's hard to understand exactly where you stand when when you pick up the phone to someone, they immediately charge you £95. So yeah, I think there's work to be done there, and as Sue said, I think we need to help them, and fortunately for us, because we've been running for a while, we do have a lot of data to support what we're doing. But as we step into something that's less known, certainly we need to work together and provide them with support as well. So yeah, that's what I'd have to say.
Great, thanks, George. And I think we've just got time for one more question, which comes from James Moon, and about environmental monitoring. He said that the focus of test centres is on technology development and testing devices, but have there been any environmental monitoring technology companies also testing their equipment at your sites? And I think a couple of you did mention environmental monitoring, but has there been any actual development in the technology that is used for environmental monitoring to get, and the sort of equipment that we need to get the data that we need? Can I come to you, Rob, first?
Yeah, sure. It's probably a question I'm not qualified to answer, but I'll have a crack anyway. You know, in a sense, most of the environmental monitoring equipment that we're using has been designed for another sector in the first place. So there's a challenge there around how you adapt that equipment, and you know, there are some standards and protocols that are developed for how you conduct these kind of surveys. There's a lot of R&D, I suppose, in that kind of area. I can't point to anything specific, I would say, that's been developed specifically for a testing program at Emac. I think by the time we're trying to do environmental monitoring, there's such a challenge in collecting that data in the first place, and your real aim is to try and make sure that it's of such high quality, you know, that you can extract good analysis from it. That you know, the more off the shelf and kind of, you know, coming with warranties and stuff like that you can get, the better. Having said that, I'm quite sure there would have been novel equipment tested at Emac. I just I'm not able to point to anything in particular. In terms of, you know, developing that kind of equipment, I know they've done a lot of that in the US recently at PNNL at their site in Squim, and the DOE have funded a kind of an environmental instrumentation testing program. I'm quite keen to look at this as well at Emac, but maybe some of the other sites have more specific examples.
Yeah, thanks, Rob. John?
Yeah, I suppose that's something. Yeah, I suppose we have probably more of a focus on that because of the underwater cabled observatory allows that kind of connection of sensors to a fiber link and testing in the subsea environment. So things that we have tested in the past are novel sensors, ways of monitoring toxins associated with algal blooms. So that's kind of lab on a chip technology. So that's really at the high end of things. We've tested underwater camera systems, novel camera systems, acoustic monitoring systems as well. ADCPs, or one company was looking at a Doppler velocity profiler and its potential application as an ADCP, wave riders. So different ways of, I suppose, technologies for monitoring the environment. Different types of sensors and equipment as well. So, and one thing I'm just going to add on the testing of components and sensors is there's a huge benefit to the local supply chain in terms of the innovation potential. Because one thing that has come out of some of the tests that we've done is new companies have started up, or companies with existing, say, communication technologies are now entering the renewable industry through testing at their products at the test site. So we're trying to kind of marinize products that maybe have different applications, take them into the marine environment. They get to work with, they get, I suppose, a better handle on what it takes to marinize their equipment. And I think that's a massive opportunity, both in terms of, say, sensor packages on wave energy devices, how you collect all of the pitch, the roll, the heave data. You know, we've had companies that have actually developed new technology on the back of that, and they're then kind of expanding their service offerings. So just was something I thought of there, that the testing of different types of sensors and equipment and the instrumentation of devices has spin-outs in terms of local supply chain benefits.
Okay, John, thank you very much for that. And that, I think, brings us to the end of our time. So just to finish off, to thank you all the panelists again for their presentations and the useful discussion there at the end. And I'm going to hand back to Jay